Hey guys, so I thought I'd just tell you about something that happened this week. A guy called Paul contacted me via email and he was trying to use the U-blox GPS module. I covered one of those in a video a little while back. I'll put it up in the video corner bit or something. And he wanted to be able to record that data onto an SD card and put it into Google Maps for later on. He was using some kind of plane or something and he wanted to be able to sort of map it out afterwards and show where it had come from. So I thought I'd, in order to sort of debug his stuff so that it would work, I had to rig up my own. So we've got the little U-blox module here. I've got a little SD card reader and writer, obviously, and my Uno and a little breadboard just to put the wires on. Now, I've done some code for this, so it's already sorted. We did that back in that other video, but not writing it to the SD card or formatting it for a CSV. That's a comma separated values sort of spreadsheet deal. And we can import that using something called Google Fusion tables, which will automatically map your data if you put some sort of location data in there. So I'll plug this in, I'll let the GPS get a fix, and then we'll start looking at the code. So this is our basic setup. We've just got one of these little SD card readers. The card's not in at the moment, it's in the computer. But this has level shifting on board and it also has a voltage regulator. So I can plug it directly into 5 volts. We've got our master out slave in, our MOSI connected to pin 11, and our MISOs, or master in slave out, whatever you want to call it, is connected to pin 12. Our clock signal is connected to pin 3 and our chip select is connected to pin 4. On our GPS module, which we've got right here, we're connecting via software serial. So it is powered by 3.3 volts and we've got our RX line from the module going to pin 3 and our TX line from the module going to pin 2 on the Arduino. Right, so we've got the code here. We're including our software serial as we did before with the GPS module, but we're also including SD and SPI libraries so that we can communicate with our SD card. Now we specify our data file up here. This is sort of a modification of some of Paul's code that he sent me, and I've integrated with my own. So we're looking at a different NMEA string this time. He wanted to pick up some altitude data. So we've got sort of an array here of labels for the data, and above we've got the array that's going to hold the NMEA data itself. But we're looking at the GPGGA string this time. Now that's this one here, the Global Positioning System Fixed Data. Now this one includes altitude data, but it also has this, which is a fixed quality flag. Now I think this is a little out of date because it can go to a higher number than this, but it has 0 for invalid, so that means there's no fix. 1 for GPS, 1 for DGPS, and actually I think it goes up to 5 or 6 now for sort of 3D fix and things like that. So this is a little bit out of date, but it gives us the labels that we've got here. So we've got, we ignore the first one. We're looking for time, latitude, longitude, fix. But actually here I'm splitting these out because there's a comma separated here. I can pull those separate values out. So it gives us the latitude, and it also gives us latitude and which hemisphere it's in. So it's in the northern hemisphere and this one's in the western hemisphere. So we can split those out, so it makes it a bit easier when we're converting our radians to degrees later on. And so I've added all of these in, all the labels so that we can pull them out. Some of them you don't need, like the checksum there and the DGPS reference station. In fact, these two are blank, so we don't need those. But we pull them in anyway when we're reading the data. So we'll see we've got we're starting our serial bits for the GPS, and we're also going to start the SD card. So this is the standard way of writing to an SD card, just pulled straight from the examples in the IDE. And then we're setting up our file here, and we go through the separate GPGGA string here, and we pull those sections out. Now, in order to write these to the SD card and put them into a CSV file so that we can import it into Fusion tables later on, what we're doing is writing it in a very specific way. We've already set up a text file with labels on. So we've got time, number, latitude, and longitude. And what I'm doing is I'm adding in the updates, that's the number of updates it's done. So that becomes our sort of unique value for each one of our each one of our rows. And then we'll add a comma in, and that's the way that you work with CSV files. Then the first one of our values from our array, which is time. Then we're going to go for the next one along, which is latitude, another comma, and then longitude after another comma. Now, just before this, I converted those values in space 1 and 3 using convert lat and convert long, whatever it would be. And those are functions I've written down here. And this isn't from a library. You can get a tiny GPS library if you want one, but this is actually just a little bit more fun, and it helps you understand how all this code works. So they're converting those into degrees, and it's using the northern hemisphere and southern hemisphere, or east and west, and then it adds on a certain value or creates a negative and positive value instead, so that it puts you in the right spot. So we can look at the serial monitor now, and you can see what's coming out. So this is, if I just stop it auto scrolling, this is live data. It's slightly edited, so you don't know exactly where I am, but there's live data coming out. It comes out once a second because that's the update rate of the U-blox module. It comes out 1 Hertz. So if I just stop it from scrolling through, you'll see that we've got, it starts with time. We've got our latitude, north, south. It tells us we're in the northern hemisphere. It tells us our longitude and east or west. And it's got fix 1, so it has a fix. It's got, I can't remember, number of satellites it's tracking is 6. I can't remember what the HDP is. The altitude is 76.5, and it tells us what value that is. So it's in meters, or what measurement value that is. MSL, I can't quite remember what that means. And then it tells us writing done. And if I scroll up here, you'll be able to see that it starts off, if it can open the data file, it starts off by printing writing to the serial monitor. And then at the end, it will print done once it's finished. And then we close the file at the end of every loop. So let's have a quick look on the map and see where we are. So plugging those values into the map, we see that I am in the middle of a field in Charnwood Forest field, in the middle of some woods in Charnwood Forest. So that's apparently where I am right now. It isn't, obviously. And so we can plug this information into Google Maps, but how do we do it in something cooler? Well, let me pull the SD card out of our little thing, and then we'll see how it works. So here's our GPS data. This is what's come through. So I already added my titles in there. So these are column headers. And then it's added in the time, which isn't going to be very useful, but it's nice to just have that as a reference. And then we've got our latitude and longitude just there. And this has gone on for, how many seconds is this of data? 142 seconds of data. So what we can do is go to Google Fusion Tables. Oh, I can't spell. So we're going to choose a file. So Google Fusion Tables requires you to log in. So I've already logged in. So we're going to choose a file. So we'll choose GPS. And it's already detected that it's a comma separated thing. So we can just click next. And there we go. It's detected the number. We didn't really need to do that. It's going to number them down the side anyway. And then it's got our time, our latitude and longitude. So just click next. Call it GPS, that's fine. And there we go, there's all our data. Now it gives us a tab that we can click on. It says map of lat. Now I'm not sure if it's actually going to find us completely. Ah, there we are, perfect. So it has given us our location. Let's have a look at the satellite map. So we're bouncing around a little bit there. It's not an awful lot, but that's the problem when you don't have an awful lot of satellites tracking you, but it is very good. And it's mapped all of our data. Now, it's not mapping it over time, and we haven't given them sort of proper descriptions or anything, but we can see where it's been at least. And because we've got this time function in here, we can see when that first one was added. Well, I hope you found this information helpful. Mainly it's all about getting the information into a CSV file and pulling it into one of these services like Google Fusion Tables.